I'm gonna talk about two most important rules to analyze the electric circuit, and these rules are equally applicable for direct circuit and indirect current circuits. So first rule is called junction rule. So these are given by a physicist called Kirchhoff. So Kirchhoff's rule, and the first rule here is junction rule. So junction rule tells us, let's say we have currents coming towards a certain junction. So this one here is a junction, and current I2 is coming towards this junction. Let's say this is junction A, and I1 is also going towards this one, and I3 is going out of from this junction. So according to the junction rule, the sum of all the currents passing through this junction A, so this is the junction A, will be equal to 0. So if you apply this rule in this junction, you will be getting like I1 plus I2 minus I3 will be equal to 0. So always remember, the currents going towards this junction will be positive, and the currents going out will be negative. So incoming currents are positive and outgoing currents are negative. So this is one of the very important rule given by Kirchhoff. So that gives you the information about the conservation of currents or charge. Okay, so let me talk about this second Kirchhoff's rule, which is called loop rule. It talks about potential, and this is called loop rule. According to this loop rule, the sum of the potential difference in the loop, the sum of the potential difference around any loop will be equal to 0. So let's say we have one electric circuit, something like this. Let's say, uh, let me put another resistance right here, and the resistance right here is current is I, and EMF of this cell is E. The resistance is R1 here, and the resistance of this is R2, right? So according to loop rule, the sum of the potential difference across the components will be 0. So from here, if you move from here to here, you will be getting like positive E, right? If you are going opposite direction from positive to negative, you can take the potential of the voltage potential across the battery will be negative, right? This direction, it will be negative E. This direction, it's positive, right? And let's say the current is passing in this direction, which is the conventional direction of current flow, and we are moving in the same direction. Let's say we are traveling in this direction, and this is also the direction of the current. So then it will be negative because there is potential drop, right? IR1, and same thing will apply here, minus IR2, because current is also same. This is just a single loop. This is equal to 0. So based on this rule, you can calculate anything which is unknown. Might be resistances are given, and you have to calculate R given the potential of the battery, or might be you have to calculate EMF of the battery, or one of the resistances might be given and other resistance can be calculated. So this is really very powerful tool to analyze any kind of electric circuit, to find resistances, potential difference across the resistance, or any electric circuit components, or current as well, passing through certain section or certain loop. So if you know these two rules, it will be very helpful to determine these variables to analyze complicated electric circuits.